Hi everyone, I hope everyone's doing great. Missing seeing you guys every day. It's not much fun talking into my computer and sending notes this way. I wish I was actually interacting with you, but it is what it is. Okay, today we're going to look at two notes, 3.1, 3.3 A and B. I will be attaching worksheets as well. You do not have to submit these worksheets. I'll be coming up with another lab or another assignment for you to do at a later date, so these are just for your own use right now. So, first note we're going to look at here is the solar system. Now, solar system, solar means star. So, a solar system is any system of things, celestial or outer space objects, that orbit a star. We're going to look at our star system today, our solar system, and that's everything that goes around the sun. The sun is our star, it's the closest one to us. So in our solar system, we have 8 planets, the moons that orbit those planets, and billions of other little things, little asteroids, little comets, little meteors, all these things. And they all orbit the sun. It's the sun's gravitational pull that keeps them from flying out further into space. Once you get beyond the sun's gravitational pull, you're now outside of the solar or star system. Now, distances are so great that we don't use centimeters or even kilometers to measure this. In the universe, we use light years. That's how far light will travel in 1 year, and it is an incredible distance. A light year, though, is too big of a unit to use inside our solar system because everything is less than a light year apart from each other. So, we use what's called the AU, the astronomical unit. Now, from the sun, here's the sun, out to the earth, that distance through space is 150 million kilometers. It's huge, it's far. In fact, it's so far that it takes sunlight 8 minutes to leave the sun and reach the earth. So the sun's rays travel through space for 8 minutes before they hit earth, which is kind of neat. Whenever you look up at the sun and don't look directly at it, whenever you do look at the sun, that sunlight, or when you're looking at the sun, you're actually looking at history. You're looking at what the sun looked like 8 minutes ago. And right now, the sun, or the light leaving the sun, won't get to Earth for another 8 minutes. So you've never seen the sun in real time. You've always seen the version of the sun that happened 8 minutes ago. That distance, that 150 million kilometers, we just call that 1 AU, 1 astronomical unit. And then we can, so that's a base unit. So the example I give in the note here, Jupiter is 5.2 AU away. So out here, Jupiter is 5.2. That means it's 5.2 times or further away from the sun. So it allows us to compare relative distances. If we are 1 AU away, Jupiter's 5.2 away, Jupiter must be 5.2 times further away. So that's that. All right, the planets. We do have 8 planets. We used to have 9 planets. When I was your age, we had 9 planets. We had Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But they changed the ruling of what a planet is. They said that a planet has to be the biggest thing in its orbit. And because Neptune and Pluto's orbit cross each other briefly, Pluto is now not the biggest thing in its orbit. Neptune becomes the biggest thing in its orbit. So Pluto, about 20, 25 years ago, got demoted from planet to dwarf planet status. So we went from 9 to 8 planets. Are there more than 9 or 8, sorry? Very well might be. But we're talking that they are so far out there that we might not have even seen or discovered them yet, or we haven't yet. But there's a possibility they're out there. In fact, Pluto was only discovered in about 1920. It was too far out, and it wasn't until our telescopes got better that we were finally able to see it. And as we tend to now send telescopes out into space, like the Hubble, we can see further and further into space, and who knows, maybe sometime we'll discover another planet in our solar system that we previously had never seen. So our planets. The first one, the closest to the sun, is Mercury. Very, very hot. It has no atmosphere around it. It's close, much closer to the sun than the Earth, so it just bakes all day long. It's made of iron. Moving outwards, Venus. This is very bright in the night sky. We can see it at nighttime sometimes if you know where to look. And it's very hot as well. And then Earth. That's us. It's unlike every other planet. It has an atmosphere. It has water on it. It's in the sweet zone, the Goldilocks zone, so to speak, where it's not too close and it's not too far away from the sun, so the temperature is just right. Doesn't get too hot, doesn't get too cold. It's the only planet that life is on. So we do go to other planets like Mars, trying to see if life might have been there at one point or another, but so far no life has been found on other planets. Continuing to move out, we have Mars, the red planet. It's red because there's a lot of iron in the soil, and it kind of rusts and turns red. If you've ever been to Prince Edward Island, you're familiar with red soils and having lots of iron in the soil. Then comes Jupiter. So these first 4 planets are terrestrial planets. They are made of rock and metals. They are very dense. Then the next 4 planets are what we call gas giants. They're not made of rock. They're not made of metal. They are made of gases. So Jupiter's the largest of the gas giants. It's got a giant big red spot on it. It's a storm. Astronomers believe that storm's been storming, if that's a word, for over 400 years at this point. Saturn, probably the most easily recognizable. It does have the big rings around it. Uranus and Neptune. And once again, all 4 of these planets are gas giants. They're made of huge swirling masses of gas. And that is that for that. As far as remembering the order of them, quite often there's people use a mnemonic, and the one that I like to remember is my, or M, very, Venus, energetic, Earth, mother, just for Jupiter, served for Saturn, us, Uranus, and nachos, Neptune. So my very energetic mother just served us nachos. Great way to remember the order of the planets from the sun out, and a great way to remember that sometimes we need to make nachos. I don't know about you, but I'm hungry right now. All right, and the other note, 3.3b. So other objects that are in our solar system. Asteroid belt. So there is an asteroid belt, and you can see that it orbits the sun as well. So asteroids are small objects, celestial, meaning in space, so small celestial objects in the solar system, and they're made up of primarily rock and metal. They orbit around the sun, but they are much too small to be considered planets. So every little thing in space isn't a planet. They have to have at least a certain size. Pluto, as I mentioned in the last note, is big enough. However, it's not the biggest thing in its orbit. The asteroid belt is found out past Mars. So between Mars and Jupiter, it's orbiting the sun as well. And these asteroids, they could be as small as a small rock, right up to 950 kilometers across. 950 kilometers, that's like from Whitby to Montreal and back, or Whitby out to New Brunswick. So very, very big, and a regular shape. So they're not round like planets, or they are big, irregular shaped balls of rock and metal. Meteoroids. So these are pieces of rock or metal, and they're smaller than an asteroid, and they can get pulled into the Earth's atmosphere. So when a meteoroid gets pulled by the Earth's gravity into its atmosphere, as it's streaking through our atmosphere, it's encountering a lot of friction, and it gets very hot, and it actually burns up. In space, it's called a meteoroid. as soon as it enters into our atmosphere, the name of it changes and we call it a meteor. And then if it manages not to totally get burnt up, most of the time it does, but now and again a little piece will make it all the way through. If it hits the ground, it's called a meteorite. And meteor showers occur when the meteors are burning up in the Earth's atmosphere. So sometimes you might say, oh, I saw a shooting star. In all likelihood, you saw a meteor in our atmosphere burning up. Comets. These are large chunks of ice, dust, and rock that orbit the sun. Some take years, some take thousands of years. As it moves closer to the sun, the ice starts to heat up and it leaves a big gas water tail behind it, or streak. So comets look like they have a big tail behind them. Probably the most famous is Halley's Comet. I think I was about 12 when I saw it, and it takes something like 77 years to orbit the Earth. So I think I forget the actual year, you can Google it. I think we're talking 2054 or something like that. I'm going off memory, so I might be off by a couple years, or 2057 will be the next time. So I may be lucky enough to see it twice in my lifetime. It's only another 30 years away. And you'll definitely get to see it in your lifetime as well. One thing I do want to point out is, going back to this previous note, one of the neat things about our solar system is, look at this, all the planets are lined up on the same plane. So our solar system never looks like this where they're all lined up here. So Mercury may be here, the Earth may be on the other side of the moon. Here's Jupiter, but Saturn may be way back here, and Neptune may be over here. But what I mean by lined up is, look at their orbits. These rings that represent the orbits, they're all at the same level. So we don't have the Earth orbiting like this, and we don't have Neptune orbiting like this. They all have the same plane of orbit, which is actually kind of remarkable. All right, that's it, ladies and gentlemen. So you can do your worksheets, and do not post those. Just print them off if you can, or file them away in your computer and save them for future reference. Have a great day, everyone.